Hi, this is Powerland Science and Maths TV. I welcome everyone. If you are new on this channel, you are welcome. On this channel, we talk about chemistry, physics, and general mathematics. So if this is the kind of content you want, kindly subscribe to this channel. Now, this video focuses on chemistry, and specifically we are looking at the topic atomic and mass numbers of an atom. Now, before I proceed, I want to be quick to add that I have already made a video on what the atom is, the parts of the atom, and some related videos of the atom. So, and this lesson is actually a build up on previous videos. So I'll be glad if you check the previous videos on the atom. So let's move on to the topic. We are looking at atomic number, mass number of an atom. Now these two terminologies are key terminologies that are associated with the atom, even though there are other terminologies that we'll look at as we proceed. So now let's look at what an atomic number is. An atomic number is simply the number of protons in the nucleus of an atom. Now, if you take a look at the previous video I've made on the atom, you realize that I said the atom is made up of a central portion or a central part called the nucleus. And in this nucleus, there are two particles, which are protons and neutrons. Now, if we focus on the number of protons that are in the nucleus of the atom, then we are looking at the atomic number of that particular atom. So atomic number focuses on the number of protons in the nucleus of an atom. So the number of protons in the nucleus of a particular atom gives that atom its atomic number. We can also define the atomic number as the number of electrons in a neutral atom. So over here you could see that the neutral atom, or the word neutral, has been highlighted, and this is because it is different from what we have here. Now when we talk of a neutral atom, we are simply looking at an atom which is neither negatively charged nor positively charged. In other words, a neutral atom is simply an atom which has neither lost nor gained electrons. So if I give this is sodium, because there is no charge which is either positive or negative on sodium, we see that this sodium is a neutral atom. But if you take a look at this, you could see a positive charge on this sodium. So we say that this sodium is positively charged. So if we really want to associate atomic number with the number of electrons, then we are talking about the neutral atom. So this is what we are referring to. So the number of electrons you have in this atom, this sodium atom without a charge, or any other atom without a charge, is what we call atomic number. So note that for atomic number, we are simply talking about the number of protons in the nucleus of an atom, or the number of electrons in a neutral atom. If you take a look at this, we can say that the number of electrons in this is the atomic number, because this is charged, and I'll explain why we can't call it so as we go on. Now we must note that another name for the atomic number is the proton number, and the reason is because we've said from the definition that atomic number is the number of protons in the nucleus of an atom. So another name is proton number. So if you are asked to determine proton number, it's the same as determining the atomic number. So if you know the atomic number, it is the same as the proton number. Then also, another name for atomic number is electron number. But over here, the condition is that the atom must be a neutral atom, as explained here. So, if you take a look at this sodium, if I ask you to determine the proton number, it's the same as the atomic number. If I ask you to determine the electron number, it is the same as atomic number, because this is neutral. But over here, if I ask you to determine the proton number, it's the same as the atomic number. But if I ask you to determine the electron number, it cannot be the same as the atomic number. So please, let's take note. Now let's look at the second terminology, which is the mass number. The mass number. So what is a mass number? Now, the mass number is simply the sum of the number of particles which are in the nucleus of the atom. Simply put, we are looking at the summation of the number of protons and neutrons in the nucleus of an atom. So we've seen that the atom is made up of the nucleus, and in the nucleus we have protons and neutrons. So let P stands for proton and N stands for neutron. If we focus on only the proton, then we are talking about atomic number. But if you focus on the summation of the proton and the neutrons, then we are talking of the mass number. So the mass number is the sum of protons and neutrons in the nucleus of the atom, whilst atomic number is only the number of protons in the nucleus of the atom. So I'm saying all this with respect to the nucleus of the atom. Now, another name for the mass number is nucleon number. And why is that so? The reason is because generally the term nucleon stands for the particles that can be found in the nucleus of the atom. So nucleon is a collective word, or is a collective term for the particles that can be found in the nucleus of the atom. And these particles that can be found in the nucleus of the atom are protons and neutrons. So what it means is that if you put protons and neutrons together, the collective name for these two is what we call the nucleon. Is the nucleon. And you can see from the mass number that we are putting the proton number, the proton and the neutron together. And we've seen from here that the proton and the neutron are collectively called nucleon. So it is logical for us to also call the mass number nucleon number, because nucleon number also puts together the proton and then the neutron. The next terminology, which is not part of the major terminology, is the neutron number. Now, what is a neutron number? The neutron number refers to the number of neutrons in the nucleus of the atom. The number of neutrons in the nucleus of an atom. All right. So, if we are focusing on only the neutrons in the nucleus of the atom, then we are talking of the neutron number. Then, if we are also focusing on only the protons, remember, it's the same as what? Atomic number. All right. So, mostly the atomic number is represented by the letter Z, and then the mass number is mostly represented by the letter A. Electron number is represented by the letter E, and then the neutron number is represented by the letter small n. So let's take notice of that. Atomic number is represented by Z, mass number is represented by A, proton number is represented by P, electron number is represented by E, and then the neutron number is represented by the N. So let's look at calculations involving atomic and mass numbers of atoms. So we are just going to look at something like that. But before we look at the calculation, I just want you to note down the following. First of all, for every atom for which we will be looking at the mass number and the atomic number is of the form is of this form. For all the atoms we are going to look at, as far as calculations involving atomic and mass numbers are concerned, they are always of the form this. The superscript, which is the A, is called the mass number, and then the subscript, which is a Z, is called the atomic number. So an example is, if I give you this calcium 40 20, what it means is that 40 is the mass number. That is a superscript, and then the subscript, which is a 20, is the atomic number. So all the calculations involving atomic and mass numbers, the atom under study will always be of this form, or will generally be of this form. Now note that the superscript and then the subscript, they are constant. So in all questions, their values will be given. They are constants. They are constant. So I just want you to note that. So just note that all the atoms we'll be looking at are in this form. So what I want us to do is that, you know, we have neutral atoms and then we have charged atoms. So let's look at how we can solve questions related to neutral atoms and then charged atoms. So first of all, let's look at the neutral atoms. The neutral atoms. An example is what we have here. You can see that there is no charge here, so this is a neutral atom. So for this neutral atom, I've already said that the mass number is the superscript, which is A. Then the atomic number is the subscript, which is a Z. What about the proton number? Remember from the definition, we said that another name for the atomic number is what? The proton number, meaning that the proton number is the same as atomic number. So the proton number for this is the Z. Then what about the electron number? Electron number in this case, because this is a neutral atom, the electron number is always equal to the atomic number. Remember, because from the definition we said another name for atomic number is proton number or electron number. That is for a neutral atom. So we can say that the electron number is the same as the proton number, which is also the same as the atomic number. That is for a neutral atom. So this is also Z. Now, what about the nucleon number? The nucleon number. Remember, the nucleon number is the same as the mass number, and the mass number is the superscript. So the nucleon number of this atom is A. Now, what about the neutron number? Remember, the neutron number is small n. So now let me show you how to calculate for the neutron number. How to calculate for the neutron number. Now, if you take a look at the mass number, we said that the mass number is equal to the summation of the proton number plus the neutron number. That's from the definition, because the summation of proton number and neutron number. But we've also seen that proton number is the same as the atomic number. And so I can say that the mass number, which is represented by the A, capital A, is given by P plus N. But the P, which stands for the proton number, is the same as the atomic number, which is Z. And so rewriting the equation gives A is equal to the Z plus the neutron number. And so if I want to find the neutron number, it is simply obtained by making small n the subject, and that would be capital A minus Z. And therefore, if I want to find the neutron number, it is simply the difference between the mass number and the atomic number. So neutron number is always the difference between the mass number and the atomic number. So an example here, if we take a look at calcium, if I want to find the neutron number, it is simply 40 minus 20, which gives me 20. So the neutron number for calcium is 20. Is 20. Now, let's take a look at, so this is all these calculations or all these items are for when we are dealing with neutral atoms. Now, let's look at when we are dealing with charged atoms. So that is the second item. Now, for charged atoms, we can talk of negatively charged atoms. So let me still use A, Z. So the first one, we are looking at negatively charged atoms. So negatively charged atoms. Okay, negatively charged atoms. Now for negatively charged atoms, all the items we saw for the neutral atoms are the same except the number of electrons. Except the number of electrons. So for example, what I mean is, over here atomic number is the Z, the mass number is the superscript, the neutron number is the difference in the mass number and atomic number, which is A minus Z, as seen for the neutral atom. Proton number is the same as the atomic number, which is the Z. Nucleon number is the same as the mass number, which is the capital A. But when it comes to the electron number is not the same as the atomic number, which is also not the same as the proton number. So for a charged atom, what you have to note is that the electron number is not the same as the proton number, or it is not the same as the mass, the atomic number, sorry. So then how do we determine the electron number? Now for a negatively charged atom, the electron number is obtained by pick the atomic number minus the charge. So this is a general formula. This is a general formula for a charged atom. For a charged atom in general, the electron number is obtained by subtracting the charge from the atomic number. So now let's look at it. So the electron number is given by the atomic number minus, in this case the charge is negative, so, and the charge is the C, so it will be atomic number minus into bracket the negative charge, which is the negative n, and so the electron number becomes the atomic number plus the charge. So that becomes the electron number. An example is if I give you the sulfur and this is 2 minus, the electron number is simply 16 minus into bracket the charge here is negative 2, so that gives us 16 plus 2, which is 18. So for this particular negatively charged atom, the electron number is 18, whilst the proton number is 16, mass number 32, neutron number is 32 minus 16, which is 16, nucleon number is 32, proton number is 16, atomic number is 16. So all the items for the neutral atoms, they are the same except the electron number. So this is it for negatively charged atom, and over here the emphasis is on the electron number. Now let's look at for positively charged atom. So I have A, Z, and the charge here is positive, and the charge here is positive. Now the electron number, the proton number, atomic number, nucleon number, all the items are going to be the same. They are not going to change. What will change here is the electron number, and in this case the electron number is obtained by, I'm going to use this general formula, which is the atomic number minus the charge. In this case you can see that the charge is positive, so the atomic number minus the positive charge will still give us Z minus N. So for a positively charged atom, you subtract the charge from the atomic number. But for a negatively charged atom, the electron number is obtained by adding the charge to the atomic number. So 16 plus 2. Let me pick an example for the positively charged. So if I have calcium 40, 20, and it is positive 2, the electron number is simply equal to the atomic number, which is 20, because the atomic number is a subscript. So 20 minus the 2, it is positive. So the electron number here becomes 18. That tells us that calcium has lost 2 electrons out of the 20. So we're left with 18. Now let's pick general examples and solve. The first example is that we are looking at chlorine. So we are looking at chlorine, the neutral atom, and we want to find, first of all, the mass number represented by A. Now the mass number is always the superscript. So the mass number is 35. The second thing is I want to find the atomic number. The atomic number is a subscript, which is 17. Now, what about the proton number? The proton number is the same as the atomic number, which is a Z. So it's the same as a Z, and so it's equal to 17. Now, what about the electron number? Now, because this is a neutral atom, the electron number is the same as the proton number, or the same as the atomic number, which is also 17. Now, what about the nucleon number? The nucleon number is the same as the mass number, which is the A, and which is 35. What about the neutron number, which is the small n? The neutron number is simply the mass number minus the atomic number, and this is given by the mass number is 35, the atomic number is 17, and this gives us 18. Now let's take a look at another another example. Now this time around, it is the same chlorine atom, but it is negatively charged. So what is the mass number, which is the A? The mass number, remember, whether it is positive or negatively charged, the mass number is not going to change. So it is 35. The atomic number is also not going to change, and so it is a subscript, which is 17. The proton number is also not going to change, which is the same as the atomic number, which is 17. The electron number, however, will change because of this negative. Remember, the electron number is given by the atomic number plus the charge, which is 1. Remember, it's the same as E is equal to Z minus 1. So it will be Z plus 1. So that's why we have 17 plus 1. So that gives 18. Now, what about the nucleon number? The nucleon number is the same as the mass number, and so 35. What about the neutron number? The neutron number. The neutron number is going to be the same because it's given by mass number minus atomic number, which is 35 minus 17, which is 18. Now, let's solve one more example. So we have sodium positive. So we are looking at the mass number. Remember, mass number is always the superscript, which is 23. The atomic number is a subscript, which is 11. The proton number, whether it is positive or negative, the proton number is the same as the atomic number, which is 11. What about the electron number? The electron number will not be the same as the proton number or the atomic number because of the positively charged or the positive sign at the top. In this case, it is going to be Z minus 1, and that will be 11 minus 1, which is 10. So the electron number for this is 10 because you have lost one electron, and if you have lost one electron, it will be subtracted from this and you'll be left with 10 electrons. Now, what about nucleon number? Nucleon number is the same as mass number, which is 23. What about neutron number? Neutron number is mass number minus atomic number, which is 23 minus 11, which is 12. Last one, let's solve last one, which is aluminium 27 13 3 positive. Can you try and get the mass number, atomic number, proton number, electron number, nucleon number, and neutron number? So lastly, mass number is, in this case, is 27. That's a superscript. What about atomic number? Atomic number is the subscript, which is 13. What about proton number? It is the same as the atomic number, which is 13. What about electron number? Electron number cannot be the same as atomic number because of the charge. So it is going to be Z minus 3. So that will be 13 minus 3, which is 10. Now, what about nucleon number? Is the same as the mass number, which is 27. And finally, the neutron number is given by mass number minus atomic number, which is 27 minus 13, which is 14. Thank you for watching this video. Let me know any question you have in the comment section, and please don't forget to share this video, like, and if you haven't subscribed yet to this channel, kindly do so. Thank you once again.